Okay. Make sure, yeah, okay, very good. Recall what we did, I think it might have been the very first day of class, when we asked the question, what's the equation of a circle centered at the origin with radius r? Okay, so this is your x-axis, this is your y-axis, and with the radius was r, and we said, okay, how do we go about doing that? We said, well, let's do this. Let's just find a point on the circle, designate that as the point xy, and then we'll ask the question, what does the point xy have to satisfy? And the answer, if you remember the Pythagorean theorem, the answer is that since this distance is x and this length right there is y, by Pythagorean's theorem, x squared plus y squared is equal to the square of the hypotenuse, which would be r squared. And so there's the equation of a circle. Okay, remember that? So now we're going to do something similar for lines. Same idea, same spirit. Okay? We're going to say, suppose we have ourselves a line which goes through the point AB, and the slope is m. Given that, what's the equation of the line? And so we'll do it exactly the same way. We'll say, okay, let's just choose any old point on the line. Let's just call it the point xy. And then we'll ask, what does that point xy have to satisfy? And you look at it a bit, and then all of a sudden it occurs to you, oh, wait a second. I know that the way you calculate the slope is you take any 2 points on the line and you take the change in the y values, the rise, which in this case would be y minus b, and you divide that by the run, which is the change in the x values, which in this case would be x minus a, and that gives me the slope. Agreed? So that right there, y minus b over x minus a is equal to m, is what has to be true for any point xy on this line. And so all we have to do now is to multiply through by the denominator, and we're going to get y minus b is equal to the slope times x minus a. There it is right there. There's the equation. That's probably my favorite equation for a line because it's very easy to see. It's easy to understand where it comes from. You don't have to memorize it. All you have to do is just make yourself a picture, and it pops right out of the picture. And I like it in that form. If you want to, you could add b to both sides and get y is equal to m times x minus a plus b. You could do something like that. But I like this, or this, it goes right from there to there. So let's see once how it works. Okay, let's see once how this can help us find all sorts of equations. Suppose you have, for example, a line that goes through the point 2, negative 3, and the slope is 5. Again, we use m for slope, is typical. Okay, so let's get rid of this one and just use this one. In fact, let's put it right over here. So what do? We go y minus a negative 3 is equal to the slope times x minus 2. So that's going to be y plus 3. If I wanted to, I can multiply this out. It's going to be 5x minus 10. And then we can subtract 3 from both sides and get y is equal to 5x. If I subtract 3, it's going to be minus 13. So there's the equation of the line. If you want to graph it, what's the graph going to look like? By the way, recall that Desmus, I think I mentioned this to you before, hopefully your teacher has. If you go to Google and just go to your computer and type in Desmus, and it'll find it for you, and just push calculator, and it gives you a nice graph there and allows you to type in whatever you want very intuitively, and it'll graph things for you very nicely. It's a super easy and convenient, good quality tool to use. But anyway, here, let's see, we don't have that here handy, so I'm going to graph this a second. I'm going to graph, well, let's see, when x is 0, y is equal to negative 13. So there's the y-intercept. And if I want to find the x-intercept, all I have to do is to let y be 0. If y is 0, then what would x have to be? 5x minus 13. 5x is equal to 13. X is equal to 13 fifths. So 13 fifths right here. 13 fifths, 0. There's that point, and the line looks something like this. Very steep slope, slope of 5. Okay, that's the idea. Let's try another one. Let's find the equation of the line that goes through the point 2, negative 3, and 6, 5. Okay, so by the way, let's just make sure that that previous one did go through 2, negative 3. If you stick in a 2 right here, 2 right here, you're going to get 10 minus 13, sure enough, is negative 3. So sure enough, that previous one went through the point 2, negative 3. So now we want another line. We want a line that goes through 2, negative 3, and 6, 5. So what's that going to look like? 2, negative 3. Let's move it over just a little bit. Two negative 3 is right there. 3, 4, 5, 6. 1, 2, 3, 4, 5 is up there. So it goes through those 2 points. Looks something like that. Let's find the slope of that one. Well, notice we've got a point on the line, so we're all set there. The other thing we need is the slope of the line, and we don't have that. So what can we do? Well, no problem. As long as I have 2 points on the line, I can find the slope. The slope is going to be what? 5 minus a negative 3, all divided by 6 minus 4, or 6 minus 2 rather. So that's going to be 8 on top. 6 minus 2 is 4 on the bottom, is a slope of 2. So the slope is 2. So now I can go y minus a negative 3, that's going to be y plus 3, is equal to the slope, which is 2, times x minus 2. And if I solve that for y, I'm going to get y is equal to 2x minus 2. And I'm going to do 2 steps in one. I'm going to multiply this out. Oh, I got to do it right though if I'm going to do it. It's going to go 2x minus 4. Okay? And then I'm also going to subtract 3 from both sides. So here we get y is equal to 2x minus 7. So there's the equation of the line. What if instead of using the point 2, negative 3, we would have used this one? Okay, better give us the same answer. Let's check it out just to make sure. So it's going to be y minus 5 is equal to, what did we say our slope was? Our slope was 2 times x minus 6. Okay, so y minus 5 is equal to 2x minus 12. Add 5 to both sides. You're going to get y is equal to 2x. So you add a positive 5 to negative 12. You're going to get a negative 7. Sure enough, same thing. Okay? And again, you can find the y-intercept easily. It's going to be negative 7. What's the x-intercept going to be? All you have to do is to set y equal to 0, because the x-intercept is when the y value is 0. You get 2x is minus 7 is equal to 0. 2x is equal to 7. X is equal to 7 halves. 7 halves is the same as 3 1/2. 1, 2, 3. Hey, pretty close. Doggone it. Very close. So there it is right there. Okay, very good. Let's try another one. Let's say that we want the line which is parallel to 3x plus 5y is equal to 7. We want it to be parallel to that. And we want it to go through the point negative 1, 3. Okay, negative 1, 3. Well, let's see. I think we've already talked about last time, didn't we, what it means to be parallel. To be parallel means they have the same slope. So I need to find the slope of this line. Notice the slope of any line is what you get when you basically solve it for y. It's the thing in front of the x, because that tells you how the slope, how the height is changing as this changes. This slope is 2, because when x changes by 1, the y is going to change by 2. So anyway, we need to find out what the slope of this is. So let's go 3x plus 5y is equal to 7. 5y is equal to negative 3x plus 7. So y is equal to negative 3/5 x plus 7. Agreed? So that's the slope of this line. I want the same slope, but now I want it to go through the point negative 1, 3. So it's going to be y minus 3 is equal to this slope times x minus the negative 1. So subtract the negative 1 means you've got a plus 1. Let's simplify it. You're going to get y minus 3 is equal to negative 3/5 x minus 3/5. And now you add 3 to both sides. Y is going to be negative 3/5 x minus 3/5. Now you're going to add 3 to it. Adding 3 notice is the same as 15/5, right? 15/5 reduces to 3, so if I would add 15/5 here, 15/5 minus 3/5 is 12/5. So if I do that in there, it's going to be plus 12/5. Like so. Okay, so there's the answer. What if instead of one that's parallel, what if you want one that's perpendicular? So instead of parallel, you want one that's perpendicular. This is a symbol that's often used for perpendicular. Okay, they meet at right angles. So now recall that if two lines are perpendicular, their slopes are the negative reciprocals of each other. So since the slope of this is negative 3/5, the slope we would want is the reciprocal, 5/3, and we want the negative of it. This is already negative, so the negative of a negative is positive. So you do the same thing, except now my slope would be a positive 5/3. Okay? And this is meant to be kind of a overview, so this kind of thing in class where you have a little more time, I finish this through and maybe graph them both and show that indeed they are perpendicular. This is where you can use Decimus again, and so this is the kind of thing your teacher can do in class as well. Okay, very good. Let's do one kind of nice example of lines. In the Celsius system, here's freezing, here's boiling, and we also have the Fahrenheit system. In the Celsius system, well, let's start with Fahrenheit. We know that. In the Fahrenheit system, we, Water freezes at 32 degrees and water boils at 212 degrees. Agreed? You remember that? And in the Celsius, or the centigrade system, water freezes at 0 degrees and boils at 100 degrees. Seems like a much more reasonable set of numbers to use than these. I don't know where those came from. Seems kind of arbitrary. But anyway, that's the way it is. So let's find a relationship between Celsius and Fahrenheit. Let's let X stand for your Celsius, and let's let Y stand for your Fahrenheit. And so we're going to have ourselves a graph here where this is X and this is Y. And so one point on this graph is going to be the freezing temperature. Okay, freezing in Celsius it's 0, in Fahrenheit it's 32. So there's one point which demonstrates a relationship between these two. When Celsius is 0, Fahrenheit is 32. So there's a point right there which captures the relationship between these two scales, at least at the freezing temperature. Similarly, at boiling, Celsius is 100 and Fahrenheit is 212. So another point that captures the relationship is when you are at 100 here, and I'll just say it's way up here. Right there, 212. Okay, let's make this a little, well, that's good enough. Okay, there it is. So this line, which goes through those 2 points, is the line which gives us the relationship between centigrade and Fahrenheit. And let's go ahead and find out what that relationship is. Okay, how do we do it? Well, we need the equation of the line. We've got 2 points on the line, we need the slope of the line. And that's easy enough to get, because the rise over the run, change in the y over the change in the x, is going to be 212 minus 32 divided by 100 minus 0, which gives you 180 over 100. Cancel the 10s and you're going to get 18 over 10. 18 over 10 is the same as 9 over 5. So there's your slope. Okay, now that you have your slope, you can write the equation. Let's kind of compress things here. Y minus 32 is equal to 9/5 times x minus 0. If you solve it for y, you're going to get y is equal to 9/5 x plus 32. Or if you write it in terms of Fahrenheit and centigrade, you get the Fahrenheit reading is 9/5 the centigrade reading plus 32. Okay? So kind of cool. And speaking of cool, here's a question for you. Is there a temperature, and if so, what is the temperature, where if you had both a centigrade scale thermometer and a Fahrenheit thermometer, where those two thermometers would give you exactly the same reading? Is there some particular temperature where the two readings would be the same? If so, what is it? Okay? So here's basically what we have to do. This is the line F or whatever, Y, I guess I have in terms of Y and X here. So here's the line right here. There's the line, Y is equal to 9/5 x plus 32. I want to know, when are those two readings the same? When is Y equal to X? When is Fahrenheit equal to centigrade? So if I graph the line Y equal to X, it's going to have a slope which is not as high as that one. It's going to have a slope of 1. Y equals to X has a slope of 1. And I can see just by looking at it, there's going to be some temperature here where those two temperatures are the same. And I can find it pretty simply. All I have to do is I say, oh, Fahrenheit is equal to 9/5 x plus 32, and I want to know, when is the Fahrenheit equal to the Celsius? I'm sorry, Celsius here. There's the Fahrenheit formula, and I want to know, when is the Fahrenheit equal to the Celsius? Let's solve it. So I can solve it, first of all, by subtracting c from both sides. Notice that c is the same as 5 over 5 times c, agreed? Because 5 over 5 is equal to 1. So if I take 9/5 and I subtract 5/5, I'm going to get 4/5 c on this side. I really don't need that f now, I'm just looking at these two things. And then I'm going to subtract 32 over to the other side. So I'm going to get negative 32. And then I can find c just by multiplying both sides by 5/4. If I multiply by 5/4, these cancel and give me 1. So I'm going to get 1c is equal to 5/4 times negative 32. Well, that works out nicely. 32 divided by 4 is 8. 8 times 5 is 40. So it's going to be negative 40 degrees. So there you are at negative 40, where those two are the same. And that's kind of cool. Let me make sure my computer is working now. Okay, very good. So anyway, that's kind of neat. And you can do other things. You can find out when is centigrade equal to the negative of the Fahrenheit and so on. So that's kind of cool. Here's just one other thing. This is my own little problem that I just kind of thought of as I was preparing my notes for this lecture. I was thinking, if you were over in Europe, and you were getting readings from your phone or whatever else that said, 30 degrees or whatever else, this is a little bit complicated to do it, right? You have to divide by 5 in your head, and then you have to multiply by 9, and then you add 32. But notice that let's get something which is kind of close to that. Here's y is equal to 9/5 x plus 32. What's a number which is close to 9/5? Notice that 9/5 is close to 10/5. 10/5 is the same as 2. So this is just a little bit less than 2. And so since this is a little bit bigger than this, let's take a number here which is a little bit smaller. Let's take 30 rather than 32. Okay? So that would be much easier to use. Now if you heard on the radio it's 20 degrees outside, you'd say, oh, 20 degrees Celsius, 20 times 2 is 40, 40 plus 30 is 70. So if they said it was 20 degrees Celsius, that would be the same as 70 degrees Fahrenheit. Now that's an approximation, right? That's an approximation. Let's see what the actual value is. If you put 20 in here, you're going to get 20 divided by 5 is 4. 4 times 9 is 36. 36 plus 32 is 68. See that? So if they said it was 20 degrees Celsius, the real value is 68. And if you use this approximation, you would calculate 70. So you're in the ballpark, right? You're in the ballpark. So the point is, those are two lines that have almost the same slope. You have a y-intercept which is a little bit less, but a slope which is a little bit more. And so at some point they're going to cross, but even, this area where they haven't, they've crossed, but the difference, I probably exaggerated it here. In fact, I can tell. They're still close together. In fact, let's see once where they do cross. Where would they cross? What did I just say? We had 9/5 x plus 32, and I want to know my approximation is 2x plus 30. Those are the two lines, and I want to know when are those two lines, when do they cross? Let's solve it. 2x is the same as 10/5. 10/5 minus 9/5 is 1/5. So here you're going to get 1/5 x. And if I subtract 30 from both sides, I'm going to get 2 over here. Now if I multiply by 5, I get what? X is equal to 10. So right here at 10 degrees, let's check it out. If you put 10 in here, you're going to get 20 plus 30 is 70 Fahrenheit. If you put 10 in here, 10 divided by 5 is 2. 2 times 9 is 18. 18. Oh, what did I say? I did that wrong. If I put 10 in here, what do I get? 10 times 2 is 20. 20 plus 30 is 50. So if we heard on the radio that it's 10 degrees Celsius, that would be 50 degrees Fahrenheit. Do the same thing here. If I put a 10 in here, 10 divided by 2 is 10 divided by 5 is 2. 2 times 9 is 18. 18 plus 32 is 50 again. So you get 50 both places. See that? So anyway, so that's not a bad approximation for kind of room temperatures, okay? Very good. So next time we're going to get into even more examples of where lines can be used to model the real world, and that'll be all we do for lines. Very good.